my ship. Okay. So, welcome to the USS Hathaway. This is going to be our, oh, for Pete's sake. Hey, there we go. Welcome aboard, everybody. If you don't believe that this is a real ship, go ahead and Google it and you'll find images. Some of the images that you'll see include things like this. This is our ship right here. And this one here is another version of it. You can see we've got our super warp drive thrusters in the back. And they're going to help us get to our locations in no time at all. Another nice little image.
That's the thing from WALL-E.
It is kind of like WALL-E, isn't it? Now, a couple of years ago, we actually ran into some angry aliens out in space. And what we had to do, this ship right here is our friend. And what they did is the aliens wanted to destroy us, and they made a pretend explosion, and we just ducked out right behind it. So it was a good time. Either way, welcome aboard the USS Hathaway. Hopefully we don't run into any bad guys. So, here is our ship from a side view. And obviously we are going to start our trip on Earth. So you can see us there by Earth. And we are going to turn on those warp thruster things. And we land near Mercury. And that's what you can title your notes. Mercury is the rocky planet. You can probably guess why they call it that, because it's rocky. Yeah. Also like the Rocky movie series. So for this slide, you can go ahead and write down just the first 2 bullet points for each of these planets. We go a little bit into their Greek and Roman history. Oh, that get all the way around. What's that? Oh, I'm doing good. How are you? Good. Make sure you get the mask up. So Mercury moves very quickly in the sky. And the reason it moves so fast is because it's the closest planet to the sun. The closer you are to the sun, the faster you're going to be moving in your orbit around it. And so because it moves so fast in the sky, they named it after the Roman god of commerce. So anybody know what the Greek equivalent is to Mercury? What's that? Hermes, there you go. The surface is terrestrial, it is cratered, it is rocky. No surprise there, you can skip this slide. Again, you don't have to write stuff down until I tell you to do so. A couple things that you're going to find on Mercury include craters. You're going to have plains, there's some highlands, some valleys, some mountains, but overall, as we approach Mercury, you're just going to see a lot of craters and stuff. It's not going to look too dissimilar from our moon. One thing that you do need to take note of, and one thing that we do when we go to each planet, is we look at something that's specifically really, really, like, something big on that particular planet. And Mercury, what that is it's something called the Caloris Basin. Go ahead and write down this slide. So you can kind of get an idea of how big an asteroid needs to be to make an enormous crater. So this crater is 960 miles across. You can see the rim of it right here as it goes around. Roughly the size of Texas. If you want to think of it in terms of Wisconsin, it's about 3 Wisconsins wide. So it is a big, big crater. On your handout, you'll see the next couple pictures as we get to them here. But if you see one side has Texas on it, on the left, with a little dot going around it in a circle, and that kind of shows you the rim of the Caloris Basin there. So that's this one overlaid on the actual crater. And this is kind of a nice image too. This is the same picture from before, but they used a false color thing to point out where that entire crater is located. So you can see it's just an enormous part of this planet right there. Even though it's not even 1,000 miles across, it still takes up a huge swath of it. You can probably guess this because Mercury is a lot smaller than the Earth. A little bit of a sunrise on Mercury's surface here. You can see there's no atmosphere to speak of. Probably have you write that down eventually. You can do this one too. Yes. Oh, perfect. Does this miss anybody? Awesome. Oh, this is perfect. This is the sort of thing people who want to give out money to schools look at, and they're like, we're totally giving them all sorts of money. That's one thing that a lot of people don't realize is there's a good amount of grants out there for schools looking to expand things like a science department, and getting a nice big telescope is a really good reason to get some extra money for that. Hopefully something comes of it. We'll see. So it spins on its axis in 58 days, 15 hours, orbits the sun every 88 days. So a year on Mercury is a lot shorter than a year on the Earth. But a day is a lot longer. Mercury is not spinning nearly as fast as the Earth is. As far as this slide goes, just know that it's the closest planet to the sun. If you know that already, you don't need to write it down. Otherwise, just write down first planet. Yeah.
You should turn the third floor pool into a planetarium.
That would be so cool. How many of you guys have been to a planetarium? Raise your hand.
Yes.
Just a couple people? Okay. We did that for our end-of-year astronomy club party 2 years ago. It was a good time. For this slide, go ahead and write down size and then write down the diameter. You don't need to do the percentage for this one. Do size, and then do the actual diameter. You don't need to do the percentage. So you can kind of see the difference in size there. Mercury actually ends up being roughly the size of our own moon. It's just a little bit different, but in terms of something this size, one thing that I ran out of time to say when we were talking about the moon, remember at the end when I had you write down how it's the same size in the sky as the sun? That's one of those things where, you know, it's easy to just think of that and brush it off, but the odds of that occurring by chance are like zero. That's one of those things that you look at and you're like, that's something that points to a creator, where you have both the moon and the sun appearing to be the exact same size in the sky. And there's the odds of that occurring by chance are zero, basically. And it's not like it just happened for fun either. One of the other things you wrote down is how a solar eclipse helped Einstein prove his theory of general relativity in the early 1900s. So science has advanced because of this. If it was a little bit bigger or a little bit smaller, you wouldn't have a full solar eclipse, and we wouldn't be able to figure some of those things out. But it is. The moon is actually 40 times smaller than the sun, but it's 40 times closer to us than the sun. So they look the exact same size in the sky. Volume, you can skip this one, but you could fit 17 Mercuries inside the Earth. Average density is 5.43. This is roughly about what Earth was, so it's a very rocky place. Not too much water to speak of. Any guesses on how hot it gets on Mercury? How hot do you think it gets during the day? I heard 2,000. What else? 7,000? 2001. So, Mercury during the day gets awfully hot. 801 degree Fahrenheit during the day. Exactly. That's actually how I think about these temperatures. Those of you who do a lot of frozen pizza like I do know that you got to cook those things at about 400 or 425 degrees. So this is roughly twice your pizza cooking temperature.
Man, we just love using
So if that's how hot it is during the day, how cold do you think it gets at night? 700, 500, negative something? At night, your temperature on the closest planet to the sun is negative 315 degrees.
I wish you would get that cold heat.
That's cold.
What was that?
Negative 315.
Wait, how can you get that cold?
That's a good question. Anybody have a guess as to why it gets so cold?
Is it like the other side? It gets that like the, you know, never mind, forget it.
That's okay.
Never mind.
Yes. Exactly. Without an atmosphere to keep that heat in, it has nowhere, it's not going to stick around. It's just going to leave. Remember how we mentioned a while ago, if it's cloudy out on Earth, you'll notice a smaller temperature difference from day to night as opposed to if it's super clear. If it's super clear and there's no clouds in the sky, you'll notice a big temperature difference at nighttime because all that heat is free to leave. Same thing is kind of true on Mercury, but when you've got no atmosphere to speak of, all that heat is going to be gone completely. Negative 315 is what you have to deal with if you spend the night there. No atmosphere. You can write that down too. Oh, did I tell you to write down the temperatures? If I didn't, you should write those down. Again, during the day, it's 8:01. At night, it's negative 315. You should know those. Another interesting thing we look at is, now that we're on Mercury, the sun is going to be way bigger than it is on Earth, because Mercury is like a third away from the sun if you would compare it to Earth. So if this is our beautiful sun, and Earth is right here, Mercury is probably right about there. So like if this is 100, if our distance from the sun is 100, Mercury would be 30-something. So it's quite a bit closer to the sun than us. So when you compare the difference on how big the sun's going to appear, on Earth, the sun would be like this. If the sun is this size on Earth, this is how much bigger it would look on Mercury. So that's a big, big sun. You don't want to stare at it. Try to resist. When can we see Mercury from Earth? We can see it at dawn and we can see it at dusk, but these are the only two times. Yeah, write this one down too. Just the two. Just dawn and dusk. That's all you should know. So the reason that we can only see Mercury at dawn and dusk is because Mercury is a lot closer to the sun than we are. You know, it's right next to it there. So what it's going to do is it's going to follow the sun wherever it goes. So if the sun is setting, Mercury is not going to be far behind. If the sun is rising, Mercury is not going to be far ahead. It's always going to be near that sun. You're never going to see it up at midnight. It's always going to be close to the sun. You can only see it at dawn and dusk. And even then, it's got to be, really far away from the sun, proportionally speaking, to actually get a good view of it. Because oftentimes it's like in line with the sun, and you would never be able to see it because it's just obscured by the brightness. Yeah. Yes, that is Mercury right there. If you do see Mercury in the sky, it's just going to look like a faint star. Oh, yeah. There's another picture of Mercury. You can kind of see how bright it would look. Looks like a dim star in the sky. You can skip that slide. But again, you can see it's on the horizon. It's probably dusk is what that looks like. What does it look like with a telescope? Just a blob of light, no features. You can skip this slide too. It does go through phases like the moon. So what you would notice, even though you can't see like individual craters or things, any planet that is closer to the sun than we are, we would see it go through the same phases as the moon, where one side would be lit, maybe it looks like a crescent for a while, and Mercury's no different. Eventually you would see it looking just like the different phases of the moon. It's just one of the things that happens to planets that are closer to the sun than we are. You can write this whole one down. So if you did land on Mercury, during the day the sky is going to appear black because that's just what the sky is going to look like if you don't have an atmosphere to give it any color. But at night, you get a kind of interesting sight here. If you're there at nighttime and you're able to somehow stay warm, you would see around the horizon, all around you, it would look like almost like little flickers of fire coming up from the horizon. And the reason for that is because it's really close to the sun, which is shooting off all these different particles, and we call that the solar wind. And when the solar wind on the sun interacts with the magnetic field on Mercury, more specifically the sodium particles, you get this effect that occurs all the way around the horizon at nighttime. It's an interesting thing. For this slide, go ahead and write down 38% of Earth's gravity. So if we weigh 100 pounds on Earth, you'd only feel 38 pounds on Mercury, which would be kind of a neat little thing. You're not going to be able to jump quite as high as you would if you were on the moon. Remember, on the moon, you'd probably get up to higher than 10 feet. Mercury, you're just going to be able to get maybe 5 feet or so. Go ahead and write down 2.6 times your jump height on Earth. It is a geologically active place. When you look at it close up, it looks like it's pretty dead, but it's not until you do some very accurate measurements and you start taking some pictures with things like spectroscopes and fancy scientific equipment that you're able to see some of the activity going on Mercury. And we'll see an example of that in just a little while. From this slide, the main thing you need to write down is that Mercury has a higher iron content than any other planet. Kind of looks like a big jawbreaker, doesn't it? Yeah. But it does have a rocky crust, silicates in the mantle, and the core, which is a massive amount of the actual planet itself compared with the other planets, is going to be molten. So it's very hot, very pressurized. As I mentioned, when we were talking about that halo effect that occurs around Mercury at nighttime, it occurs because Mercury has a magnetic field. And this is just a little diagram that shows the magnetic field on Mercury. And in the same way that our magnetic field has a little opening where it would funnel that solar wind to our atmosphere where we see the northern lights, Mercury has a magnetic field that does much the same thing. The only difference is Mercury doesn't have an atmosphere. So you're not going to get some sort of neat, harmless light show in your atmosphere. What you're going to get on Mercury is something called a flux transfer event. This is on your handout. Go ahead and, let's see. What you need to somehow emphasize on your handout from this slide is this right here. I know the background's black, but do whatever you have to make sure that you know you have to know that. So what ends up happening here is the solar wind from the sun is coming and hitting Mercury. Mercury's magnetic field deflects most of it, but when you combine those two things in and of themselves, you get something called a flux transfer event, where that solar wind actually goes down to the actual surface of Mercury. This is not a picture of that actually happening. This is just, you kind of get the idea. The solar wind and all that radiation is going to come down to the surface in a funnel in that way. And you get these like magnetic tornadoes that hit Mercury's surface head on. It's the sort of thing where if you did land on Mercury, you would not want to be in one of those locations by the poles, because you'd have to deal with this. You can do this whole slide. Actually, hang on, let me see. Yeah, do this whole slide. So yeah, the idea here is if you've got some of these craters on Mercury that are deep enough that they have shadows all the time and sunlight never reaches them, you have a little bit of water in those locations. It's frozen, but it is actual water. It's frozen water in those spots, and you can see them highlighted in yellow on this picture. Of course, if the sun would hit them, then that would naturally just sublimate out into space. But because it's always shadowed, that never happens. What if you land on Mercury? Well, you probably figured this. You're going to vaporize during the day, and at night you're going to freeze. Go ahead and write down what happens without a spacesuit. Just that one. So yeah, during the day you walk out into Mercury, and it's not going to take long for you to vaporize away. 800 degrees is awfully hot. You'll probably vaporize, and before you would actually melt into the surface of Mercury, you would, the liquid inside your body would start to sublimate out into space. So you wouldn't really be much of a puddle. You'd just kind of start to vaporize away. At night you would freeze. With a spacesuit, like the ones that we would normally have with us, the ones that we would take into space or to the moon or something, you would have eventual vaporization and eventual heating because they can only last for so long. And once you have like a small imperfection in your spacesuit, then it's only a matter of time before it would grow and things would become fatal for you. You can write this whole slide down. So yeah, as far as this goes, this kind of goes back to the slide where it said that Mercury is geologically active. Again, if you're just looking at it, it doesn't look that way. But when you look closer, like we do in this picture, and this is a false color picture shown to emphasize the gases escaping from certain rocks, we notice that it is geologically active. We've got gases escaping from different locations in this planet, and if Mercury actually formed over billions of years, then all of those gases should have escaped a long, long time ago. Millions and billions of years ago. It shouldn't still be happening now, but it is. Points to a Mercury that's much younger than the secular story indicates. A couple other little interesting things about Mercury. Mercury was only seen, only one half of the planet was seen until 2008. Because when we actually went there before 2008, it was just a flyby. We didn't wait long enough to see the other side of Mercury being lit. Because remember, Mercury spins very, very slowly. 55 days for it to turn around for one full rotation. So we'd have to wait a while. But in 2008, they were able to take a picture of both sides very nicely. Its orbit helped Einstein prove the theory of relativity, and the Hubble telescope cannot look at Mercury. Why do you suppose that is? That's right. Yep, it's far too close to the sun. The sun is super bright. If you point... What's that? No, don't write any of this. If you point your telescope right at Mercury, you're going to have a lot of light coming in there from the sun that are going to overload its sensors. So they got to make sure they don't do that. This is the last thing that you can write down. Mercury comes in first place for several things. And all three of these have to do with Mercury being really, really close to the sun. It moves fast because it's the closest planet to the sun. Here, of course, it is the closest planet to the sun. And the shortest year also because it's moving very quickly, really close to the sun. Comes in second place for a couple things. You don't need to worry about these. But yeah, that is Mercury. A little bit bigger than our moon, but still an exciting place to be. Quiz on Mercury coming at you tomorrow. Don't forget about the part on your handout that I told you to emphasize.